Pretty good. How are you?
All right. I'm Justin Roy, work with CK. Kevin Showers works with Victor from Thermodyne. So he's going to chime in every once in a while and give some input as well. So we'll go ahead and get started. We'll start off first part in here, and then after we're done in here, we'll go out to the lab and we'll actually fire the stuff up. Okay, the reason why we're putting this seminar to start off with is, did you guys hear anything about the explosion with the acetylene? Okay, happened on the 22nd. Calcium carbide, the product that's used to make acetylene, well, that's where the plant that produced 75% exploded. So we're trying to look at alternative solutions, which have been around for years. There might be some newer stuff that's recent in the last 5-10 years that we're taking a little better look at. Okay, the alternative fuel gases that you may have heard about, Blue Flame Plus, that's actually a Chemtane 2 product. Okay, that's the alternative fuel gas that we're leading out with. You also have propylene, propane, natural gas. Have you guys ever heard of any of these?
Mm-hmm. Yeah, use it.
Okay, what about the use? Have you guys used them? Any advantages, disadvantages? What's your guys' thoughts on it?
I basically use propylene more than acetylene.
Propylene,
Yeah.
got the acetylene.
Hell of a nice cut.
Okay,
But I don't think I like the acetylene better.
and why is that?
Because it just feels like it's easier to cut. It gets hotter, it burns hotter. I mean, it feels different, you know.
It is a different technique.
You know.
That's true. Have you guys used both of them?
Yeah.
Okay. With the Blue Flame Plus, you're not going to see too much difference between that and the propylene. So if you use propylene quite a bit, it's going to be an easy transition to this stuff. Okay, and as you guys know firsthand, you have to change some of your cutting technique, your lighting procedures on the torch. So we'll get to that a little bit later. Okay, when I talk about the flame, we got the primary cone, which is right in here. Okay, then this is going to be considered the secondary cone. Okay, just that way we're on the same page, we know what we're discussing. Here's a nice little chart. It gives you the Blue Flame Plus, some of the characteristics of Blue Flame Plus, acetylene, propylene, propane, natural gas. Now if you look at the overall heat, the flame temperature, the Chemtane 2 is going to be, they claim it's slightly higher than acetylene. I can't guarantee that. From what I've seen, it's going to be really somewhere between acetylene and propylene. Okay, like I said, it's very, very similar to the propylene, and as you match everything up, you're going to find that out as well. Okay, our stability, our flashbacks, all right in line with the propylene. Really the oddball on that is going to be your acetylene. Okay. Okay, so we're going to talk about some of the advantages that we have of acetylene, why we're going to be using it quite a bit. We have the highest primary flame temperature, that primary flame, that small inner cone that you see. Okay, that's going to be 507 degrees Fahrenheit roughly. And we talk about Blue Flame Plus, propylene, the alternative fuel gases, usually they're about 100 degrees lower, somewhere in that ballpark. So that primary flame is going to be much hotter with acetylene. Okay, and you're going to see it. Sometimes that's why it starts a little bit quicker. You have a more focused heat with the acetylene. You have the ability to oxy-fuel weld. You guys know why that's the case, why you can do that with this one and not the others?
It's hotter?
No, nothing to do with the temperature. It's actually more to do with the carbon that's in the acetylene. The carbon kind of acts as a shielding gas in a sense from the outside atmosphere. That's why you can weld with it. You don't get all the porosity that you would with the alternative fuel gases. Okay. You have that focused heat pattern we just talked about. Your disadvantages, the biggest thing right now is the shortage, or if there's not going to be a shortage, there's going to be a price increase. There's no question that we've already seen that come across. Okay. Any new customer that we're turning away for the acetylene. If you don't have a contract with us currently, we're just not going to provide it for you because we're on allocation how much we can have. So we don't want to take on any new business currently. Okay. When you get above 15 psi with acetylene, it's a very unstable gas. All it takes is a blunt force on the line, then you can have an explosion. Okay, it's a very unstable gas in general. And that's why when we look at acetylene regulators, you have the little red line. Where's your red line at?
Or somewhere.
It's like 14 right around there, ain't it?
15. Okay, 15 PSI and above. That's why it's on there for a reason, so that way it stands out at you and you don't want to crank it above. Now the one thing that is nice, even if you do crank it above, and Kevin can testify to this, you're not going to get more than 15 PSI. Okay, with the, what is it, the spring, the diaphragm?
Yes, the spring and diaphragm combination of an acetylene regulator that does not let you go over that. It's an industrial standard.
Okay, and then also, whenever you return that cylinder back to CK, you're always returning 20% of the acetylene in the cylinder. You cannot draw it completely out. Have any of you guys ever seen an acetylene regulator? Or not a regulator, no, but inside of the cylinder?
It's foam.
If you take a look, you've got a porous material on the inside of this acetylene cylinder. Okay, you're not going to have that with the alternative fuel gases. It's going to be hollow. Okay, and this is going to be filled with acetone as well to help create this stable environment for the acetylene gas. The cylinder is going to be much heavier due to that as well. Okay, the other thing that we cannot do with acetylene, you can't go more than 1/7, draw more than 1/7 of the contents out of the cylinder per hour. Anybody know what happens if you do that? That acetone will be drawn out as well. You get the acetone drawn out of the cylinder and in the equipment, you're going to have to send the equipment in for repair or replace it. Okay, so you're going to damage it. You're going to damage the hose, the regulators, the torches, the whole works. Okay, so it's going to be properly cleaned, nothing that you guys can do. Okay. Okay, we'll talk about Blue Flame Plus. Talk about the advantages. Typically, when you get above 1 2-inch material, you're going to see the cutting speeds are going to start to increase. Down to about 1 inch, they're going to be relatively the same as acetylene. And we actually tried an experiment here a few years back with all the alternatives, and they were pretty close, up to about 1 inch thick. Okay, you're going to use relatively the same equal oxygen pressure. It may be slightly higher, maybe 5 psi, but it's not going to be a drastic amount. We're going to have reduced handling storage. The reason why, if you take a look at the cylinder, we can hold more gas in the same size Blue Flame Plus cylinder as we can with acetylene cylinder. Okay, so it's going to last longer. We'll get on that ratio a little bit later. Okay, we had the high flame temperature that we took a look at on the chart earlier. When you cut with this stuff, you guys know firsthand, when you cut with propylene, okay, how much slag adheres to the bottom of the steel? With propylene it does?
No. No, depends on how you cut.
If you got everything set correctly in your torch, good cutting speeds, you have a minimal amount.
Yeah.
Okay, you're going to find the same way with this Blue Flame Plus. Okay. It burns clean. You don't have any soot or the smoke like you do with acetylene. Flashbacks are going to be significantly reduced, almost non-existent. One of the biggest things is you're not restricted on your pressure settings on your regulators. You can crank that guy up to 30, 40 psi if you need to. If you have a high heating application, you have one of those multi-flame rosebuds on your torch, you don't have to worry about the 15 psi.
Do you use the same gauges?
You can use an acetylene regulator.
Typically though, so if they brought it out, were they all regular acetylene gauges and everything attached to the Blue Flame tank?
It is the exact same fitting.
Okay.
So yes, you can do that. The CGA, the Compressed Gas Association, okay, they're kind of the standard on the cylinders, what size, the fittings, the valves, all that stuff. They would like, their recommendation is this: whatever fuel gas or any welding gas, even for that matter, whatever that regulator is attached to originally, it should stay with that gas. That's their claim. If you wanna switch over to Blue Flame Plus, you know, it's up to you guys and what you wanna do, but you can take that acetylene regulator, put it on the Blue Flame Plus, make sure we have the correct hose, and we'll get into that. We have to change our tip, and then you could operate the equipment safely. Sure.
So Blue Flame Plus have the same tip as propylene?
Yes.
It does?
Yes. It's gotta use a two-piece design. Okay. The disadvantages, we cannot oxy-fuel weld, just like you can with propylene. Your real thin sheet metal, your gauge stuff,
Warps is real bad.
well, you won't get a clean cut. It'll warp it, and it'll just want to melt it out. Okay, but anymore with the newer technology, guys are using plasma cutters for this. So you're really not using oxy-fuel equipment to cut the gauge material. The other thing that I've noticed, if you get heavily rusted material, your cutting speeds are going to be slightly slower with this gas. And that's propylene same way. Heavily rusted because all that heat is in that primary flame with the acetylene. It seems like it burns it off ahead of itself a little bit quicker when you're making the cuts. Okay, but other than that, I haven't really found any drawbacks. I mean, I'm sure there's going to be special applications where it's not going to fit, and acetylene's going to have to be the primary gas. But if you're doing standard plate cutting, pipe cutting, you know, this stuff is going to work just as well, if not better. Okay, we talk about some of the consumption, how much cubic feet's in the cylinders. Depending on the size, a 100-pound cylinder, the Blue Flame Plus, which is going to be the bigger one, to a 300 cubic foot acetylene cylinder, which again is the larger size, the ratio is about 5 to 1. I've even read somewhere where it's 7 to 1. It has a lot to do with the cubic feet. It's a more efficient gas, meaning that your cutting speeds are going to be increased, higher BTUs than with acetylene. So that's why the cylinder was actually going to last longer. Typically, a 100-pound cylinder has about 883 cubic feet. A 300 cylinder has 300 cubic feet in it. Okay, so right there's a simple math. You know, you're getting almost 3 times just from the cubic footage in the cylinder itself. So one of the misconceptions that people have is you're going to go through more oxygen using the alternative fuel gases. In reality, that one fuel gas cylinder is outperforming the acetylene. That's where you have to keep that in mind. You might be, like I said, using slightly higher pressure, but it's not going to be a drastic amount. And the other thing is most people, whenever they use acetylene, they don't even set the pressures correctly. They crank the fuel gas up to 15 and they might have 60 PSI run on the oxygen to cut 3/8 half-inch material. So they're already using more than they need. And the cut quality will go down. I can't tell you how many times I find that going out to our customers to see what they're actually doing. Okay, so what change do you need to make going from acetylene to Blue Flame Plus? Okay, our lighting and shutdown procedures, which we'll discuss that when we get out there to the equipment. T-grade hose must be used. Typically, you're going to find R, RM, or T-grade hose. 3 most common that you're going to see out there. RM is designed for acetylene only. T-grade hose can be used for any of the fuel gases. It doesn't matter. The inner lining of the hose is different. T-grade is neoprene. RM it's a rubber liner. Okay, those alternative fuel gases will eat away through that rubber lining over time.
So ideally you need to change your hoses.
You may.
Why? I mean, if you don't have the T grade.
Yes, if you don't have the T grade, you need to change it. And I mean, if you guys, I don't know if they've been buying stuff from CK, but in the last probably 4 to 4.5 years, we just switched over to T grade only for the safety side because too many people were going between acetylene and propylene then, so we just standardized across the board and said we're only dealing T grade. Tip design is going to be 2-piece design, just like you have with the propylene. That is a propylene tip. We took a picture of it just the other day. Here's your acetylene tip. Okay, you guys work with both of them, so you know what they look like. Okay, you guys have any questions over anything so far in here before we go out to the lab and actually fire the torches up? Nothing? Okay, well, let's go ahead and we'll make our way all the way to the